Hello, and welcome to Physics with Ryan. Today, on Physics with Ryan, we found out how much power I had. Now, to do this, we did an experiment where I ran up some stairs. So, let's think about the forces acting upon myself as we went up the stairs with gravity. So, here's me, a little happy guy. Got a big smile. I got some arms, some fingers. Only have 3 of them. Some legs. Actually, they're pretty long, pretty buff too. There you go. Look at those quads. Got some swaggy shoes. Right on. Okay, so up here we have the normal force, as represented as Fm. Down here, we got my fat booty, so FW is my weight, because I'm a big guy. So, we'll put the stairs right here. So we got some stairs. That one's kind of messed up, but I probably just like stomped on it because that has so much power. So, here we have me going up the stairs. This is the applied force. This is my FA. And now that applied force is going to push me up the stairs. It's going to get me going at that angle way up there. And now, acting against me, I got some mean old friction. Ooh. Friction doesn't like me. It's the opposite of me. It just pushes me back, holds me back. Don't let anyone hold you back in life. You're a shooting star. Okay. So, to find the power, we have to use the formula. P, power, is equal to work over time. So, to do this, we need to find both time and work. So to find work, we use the formula, work is equal to force times distance. So, to get the force, we use our force of weight. And because I'm super fat like that, I weigh exactly, let me get some drum roll please. Drum roll please.
That's you, man.
Drum roll.
Okay.
Can I get a new band?
Oh.
Thank you. Thank you. I weigh exactly 725 newtons. Okay, so we found the distance of each stair to be 18.5 centimeters, which is also 0.185 meters. Wow. So now we have our distance. Oh wait, sorry. Oops. That's wrong.
Oh?
Well, that's only one stair. I climbed 15 stairs. So we took this 0.185 and we times it by 15. So that is equal to, drum roll please. Oh yeah, 2.775 meters. Okay, so now we have our distance, okay? So, we have our force, and we have our distance, which means we can find work now. So work is equal to 725 times 2.775, which means work is equal to 2,011.875 joules. Okay, so now we have our work. We got that all covered. And now, we found our time by having me run up the stairs and timing me, of course. So, my time, drum roll please, that's pretty great. My time was 1.85 seconds. That's pretty good. Okay, so we'll go over here now. We have our work and we have our time. So we take our power, and that is equal to 2011.8 1.875 over 1.85. And by doing some crazy mathematical calculations, I have a power of 1,087.5 watts. Bam! No.
It's good.
So, our question. An elevator motor produces 2,000 watts. How fast in meters per second can it lift a 1,000 kilogram load? So, we have our power, which is 2,000 watts, and our mass, which is 1,000 kilograms. So, we will find our force by using weight force formula, mass times gravity, 1,000 times 9.8, which will equal to 9,800 newtons. We'll use our power formula, which is force times velocity. We'll use our initial power of 2,000 equals our force, 9,800 times velocity. So you'll divide that by 9,800 on both sides, and your velocity will come out to 0.204 meters per second. Boom.
Okay, for question 7, it says use the nutritional information below to determine the following. You eat a standard serving of effective cereal with 200 milliliters of skim milk. With your personal power rating, determine how long it would take to burn off a bowl of cereal with milk. Note that these amounts are in kilojoules. So we have a bowl of cereal is 1,190 kilojoules. We would have to convert that into joules, and to do that we would have to times it by 1,000. And when he times it by 1,000, he will get 1,190,000 joules. That would be the equal to work. So then we will use the power rating we have, which is actually not my power, which is Hannah's power. She got a 712 power rating, 0.465. We will put into the formula power equals work over time. And the work we already found out was 1,190,000. Oh, it's gonna get in a bit tight now. To find out the time it would take. And that, when you use a calculator and switch the two around and divide, you get a time answer of 1,070.25 seconds. And when you convert this into minutes, you would divide it by 60. And then you would get 27.838 minutes. That's how long would it take to burn off a bowl for raisin bran? You would have to convert calories to kilojoules. So it's 250 calories for one bowl for raisin bran. We would have to times that by 4.184. We found this number on the internet. Then we have to times that by 1,000 to get joules. And the answer you get is this big number. One more cell. Forgot about that, sorry. Gotta put the joules in. Then we will use this formula, power equals work over time. And Hannah's power is 712.465. And the work we have, which is 1,460,000 joules, and we have to divide it by time. And the time that you get is 1,468 60.142 seconds. And if you wanted to get into minutes, we would then divide this answer by 60. And the answer in minutes is 24.47 minutes.